Hi, today we are here to talk about NoSQL and its role in data science. In my previous video, we had a look at what's wrong with SQL, what are the limitations of relational databases, and why should any one of us even bother looking or going in for NoSQL when we already had relational databases in place. Relational databases have been around since a very long time. They've been around at least since the 1970s and they work very well, and that's the reason why they have been around for so long. The first reason is data is represented in the form of tuples or rows, and it is well structured. It is organized into tables and it is identified by unique keys or primary keys. So what we can do is we can organize our data into tables and then join them together using these primary and foreign keys. Another very important feature of a relational database is something called transactions. There's an acronym to it which is known as ACID, and we'll see in the next slide what it is about. ACID properties in RDBMS, they are for providing the consistency and integrity of data. The very first feature of ACID is atomicity. Now this atomicity is something which sees to it that the transactions, whatever is happening, is consistent. Like for example, there's a multi-step operation. We want to transfer funds from the checking account to the savings account. So all this has to occur for one transaction to succeed. The next important feature is consistency. It means that data should always be kept in a consistent state. So which means that whatever rules and constraints have been specified when we designed the database tables and all have to be followed. The next feature is isolation. We have to see to it that the transactions don't disrupt each other. And the final feature is durability. Durability means that the data is stored persistently so that we don't actually worry about losing the data even if there is a power failure or say the data server crashes. So there are typically 4 different kinds of NoSQL databases. To begin with, let's talk about first about key value database. Now this is the most simplest form of database, and it's exactly like you're able to look up a value for a certain thing. Like for example, you have a person ID and you could look up for the first name of this person, and the values, the key value storage can be compared to how we find out the word and its meaning from a dictionary. The second kind of database is called the tabular database, or it is called a white column database, and this is probably the most similar to a relational database because it uses terms like tables and columns, but here the tables and columns, here the data is denormalized. The columns are not fixed, they can change. And we can add columns when we are working in our application. And in the case like if we feel that certain rows need different columns, we can add those columns at the runtime. And the values here can be complex structures, like it can be arrays or list. Document-based database is another kind of NoSQL database. So here what distinguishes a database is that they are able to store multiple key values in structures which is called a document. And this key can be scalar, which means that they can be simple data types like integers or strings. And the value can be complex structures like they can be lists or arrays. A fourth type of NoSQL database is called the graph. And graphs are basically networks, and so they have 2 parts. They have entities and they have relations, and we can query on links and paths between the entities. So NoSQL databases give data scientists the flexibility they need to adapt to changing requirements and while scaling to meet the compute and storage needs of their analytical projects. So MongoDB is a very popular open source document oriented database which stores data in the form of documents. Here we can see that the document consists of field and the fields are containing certain values. So this is like JSON-like structure where the data are stored in the form of key and value pairs. Unlike RDBMS, MongoDB supports dynamic schema, which means if we have a document collection of 4 fields, we can have another document consisting of only 3 fields. In RDBMS and MongoDB, we refer both as a database, but the tables here in MongoDB are referred to as collections, and the rows are called documents. Columns in an RDBMS are referred to as fields in MongoDB. So the key task we need to keep in mind from a data science perspective when we are working with a NoSQL database is that we need to collect and we need to filter and restructure the data. That is typically a unified process and which is the core of the pre-processing stage. Then it is stored in different kinds of data systems, and after that it is used for analytics or for reporting and for data mining. Another key aspect of data science and related areas is the analysis part. One of the most important and fundamental parts is retrieving data. This calls in the question, how expressive is your query language? Can you craft a query that pulls in exactly the data you want and none of the data you don't want? Another question is matching. This correlates to how you can match a complex pattern across structures such as documents, arrays, and lists. And finally, there is aggregating. Now, this is a very common operation, and one of the things we have to understand is what are the aggregation operators? Are they supported in your query language? Another important thing we need to keep in mind when thinking about task is algorithms and data structures, because the two go hand in hand. For example, if we are dealing with machine learning and statistics, we'll probably be going to use tables and data frames and other structures that are like that. But if we are more interested in real-time analysis, we'll be probably going to use queues and streams such as Kafka. And then finally, if we are doing network analysis, we'll be probably going to use data structures and data stores that are designed to support graphs. So when we are performing data science task with NoSQL, we have to keep in mind the ultimate task that we are trying to perform from an analysis perspective. So this is going to guide us how we collect, filter, and restructure data, how we store our data, how we retrieve and aggregate our information or data, and then we further on do our data analysis task. If you're finding my videos helpful in any way, please subscribe to my channel and don't forget to leave that thumbs up. It really helps.